Vertical control, vertical control. So vertical control is height. You can actually also deal with heights, even though I was saying that you can't do with just the height information without the X and Y. Why am I saying that without the X and Y? We need to know exactly the location of the toe of an embankment. I hope you understand these words I'm using. They will, I'll be asking questions like that. You should be able to just talk about it. Please have group discussions. So you know what the toe of an embankment is. I'm not going to ask you because I know you won't mind me. Okay. But of course, I'm your examiner, so I'm going to be there to ask you questions. Get into the spirits, guys. So if I want to establish that, I need to know exactly where I should have it. Then I can now look at the height at that point. Okay, so how far is the point from the center line? And then, so that's planimetry. Okay, so there you talk about the horizontal control. Then you can now talk about the height or the elevation. Then vertical control coming, i.e. reduced level. Are you okay? I know you understand me perfectly, and that's nice. Okay, so before we actually went up, we're saying that that the design points on the west can be positioned at their correct levels. Vertical control points of known elevation, okay, relative to some specified datum must be established on the site. So there are times where you can have points with known, they're actually horizontal controls, but they don't have height, so they are not, vertical controls. So vertical controls have to be treated a bit differently. Is that okay? Because you can actually establish a point, it will settle. So you put a pillar, you coordinate it, and then the pillar sinks. But it may not change in terms of X, Y, but then definitely your Y, your Z, which is your elevation, it's going to have a problem. So vertical control should be treated that way in terms of the particular points that are used for vertical controls. Okay. And so depending on where you are, which country you are, there will be a vertical control. Normally, so the datum is what I want to talk about. What is the datum? So the datum is a reference surface. Are you okay? All right. And this reference surface, you can assume it. So I'm giving you a coursework to do, and I put it on WhatsApp. Are you okay? I'm going to put it on Google Classroom as well, where you're supposed to do the longitudinal section for, the road that goes in front of the street that goes in front of AITC view. Okay, you're supposed to do a longitudinal section from the very top to the bottom, assuming that there is a control there. Are you okay? I don't want to bother you, so I would have asked you to go and now transfer a height control to that point up there, and then start working. Then you now go in the, along the center line. So this assignment is there for you to do, and obviously this knowledge goes a long way to help you. You need a datum, okay, to reference you. Otherwise, you can have two people who are, one is taller, one is shorter, and they compare their heights, and then what the short guy does, being so smart. Are you okay? I don't hate short people, I just love them. My brother isn't very tall. And the short guy actually stands on the table, and the tall guy stands on the floor. And then they compare their heights and say, okay, come on, check our heights. So you start measuring the height. You measure the tall guy's height from the ground to the head. They measure the short guy's height from the ground. No, yes, that's what you should do. But obviously, so you can't measure or compare two heights if they are not of the same, or making reference to the same level. Are you okay? So that reference level is what we want to call the datum. Is okay. So you can have heights which are with reference to a certain, the mean sea level, for example. Is okay. So vertical control is very important. You need a dumpy level. In fact, there's no need to even like reiterate or to overemphasize. If you don't know how to use a dumpy level, then of course you know that definitely you are out. Are you okay? You're not part of this discussion at all. You know that design points and works can be positioned at their correct levels. Vertical controls of known elevation related to some specified it must be established on the site. You don't have any point of known height control, then I don't know how you're going to do it. Yeah, got to find a way to do that. Sometimes architects need that per the principles of architecture. In Great Britain, a datum commonly used is what they call the ordnance datum. And in Ghana, we also have War Office and different type of datum that has been used, and they measure the height in feet and they go to survey the mapping division. So most of the height controls since, pre-colonial times, where the people who came in here, the white people came in here to assess our resource. I'm choosing my words carefully. There's been efforts to measure the country so that we know exactly where things are, to know where resources are. You see, I don't have to go into the application and the benefits of being able to survey. Okay, we get to know where our resources are. So all the levels and the sites will have to be reduced to a nearby benchmark. Okay, so you just don't measure heights, height. If you take the level instruments, you realize that the values you are reading off it are just relative. They could be anything at all. Are you okay? So hold on guys for a second. I'm just gonna record it. All right, so we need to recognize that there's something called a benchmark. So it's not a bench. You see, those who don't go for lectures, when they answer questions in exam, it's always going to look funny. Benchmark has got nothing to do with a bench. The bench that we sit on. Are you okay? So those who don't come for lectures, ask them a question, and then there they go. Are you okay? So with benchmarks, they have values, and these values are with reference to a datum normally. Are you okay? And so it's very important to have one near your site. It shouldn't be too close as to be destroyed. So like we said, we can have it. The benchmark can be like 100 meters away. Are you okay? From the site. That's close enough. 100 meters is not that far. So firstly, we can establish points of non-reduced level near and on the elements of the proposed scheme. Very important. So this is a picture. Picture is worth 1,000 words. So in this picture, you can see that we have a benchmark on the left-hand side. Okay. Press the run button here. So look at the left-hand side. You see this black thing. I'm trying to get some annotation tools to help us. So this is your benchmark, and this benchmark has a value, and the value is 50 meters. What does it mean? It means that from this place all the way to the mean sea level is 50 meters. Are you okay? All right, the reduced level. And then the rest can be added to it, but obviously this is just a sketch to explain. But you can see that the reduced level at this point is quite dangerous, isn't it? It's too close to the zero. We are almost getting negative. Oh, this one is actually 48. So, I mean, seriously speaking, when you look at these values, they should be close. Look at this one. This here is so between 50 and 40. That's 2 meters. Okay. All right. So that means from here all the way to here, it's close about 2 meters per the way I'm looking at it. All right. Now, what are we reading here? We are reading 2.5 meters here. Okay, so it makes sense, isn't it? Right. So if the reduced level here is 448 meters, reduced level here is 50 meters. It means the difference in height is 2 meters. Do you get it? That's the point being made. All right. So what we do with leveling is that you try to find the height differences. Then you can keep on working out okay, the actual reduced level at the next point. Very easy thing to do. All right. So do we need to cut or fill? Will depend on these things, these values. Okay. Let's see the calculation here. The height of the instrument, reduced level of the benchmark plus the staff reading will give you the height of the instrument. Right. So the reading here is 1.2. So this man here, it looks like an old man to me, it doesn't matter. No offense. He turns around, okay, and then he sights the staff and then reads a value of 1.2. Now that creates a height of instrument, this line here, this dashed line, of 51.2. You just simply add on to it. It's like as if you are, stacking values. You adding a value on the value. Okay, great. Now when we get that, the value that we reach, okay, the value that we reach from the staff anywhere else is subtracted from the height of the instrument, then you'll be getting the height at that point. So you can see that in this calculation, this simple calculation, yeah, in fact this one is another one, we're simply subtracting from the height of the instrument to get the actual height. This one, like I keep saying, it's not something you need to sit down and be working out. This is very easy maths that you should simply sit down as a student, solve some questions for yourself. Okay. All right, great. So here we go. Let's go to the next one. So here too, you can see another scheme. We're trying to, it's leveling. We're doing leveling here. It's okay. You read a value. Okay, 1.255. Benchmark has a height of 154. So what would be the height of the instrument? You see, this is like a question. But do you really think this question is really well? If you know what the value stands for, then you don't have to even worry about it. Okay, 154.375. So definitely that's what's giving you up there, 155.62. Is that okay? So the answer is what you get up there. There shouldn't be any question of why, but of course, if you don't get it, you can always ask. And of course, if you are quiet too, it means you understand what I'm talking about. And it's okay to understand it. It's okay, it's not complicated. All right, so we now get to know the height of the instrument. Then we need to now find the height at this point. Okay, so what is the point? It's the reading that we get minus the height of the instrument. That will give us the height, the reduced height here. Okay, then we keep on and on. So subtraction, addition, in fact, what we call the rise and the fall. Okay, we have the height of collimation. there are two ways of doing leveling. You have the height of collimation, then you also have the rise and fall. I mean, like, you need to just take the test, look at it, and then you'll be able to get it. University student. We keep going, transferring from this point all the way. Are you okay? So we get to the point of interest. So we would have transferred the height to another point to be used. Are you okay? And then with that height, now we can relate to the scheme, the design by the architect or by whoever it is, and whatever project that we are on. Are you okay? There could be a value. We need to put a bolt at a certain level. Then we can do that. So that's basically it. As with horizontal control, it's essential that the principle of working from whole to the part is adopted. So how did we get vertical controls in Midland? So when I say Midland, I mean Midland, in the middle of the land, not near shore. That's what I mean. So if we are at Sunyani or Tamale, or we are in, I don't know, somewhere in Nigeria in the middle of it, or the middle of Burkina Faso, I don't know. How do we get the values there? Are you getting that? Okay. We should also recognize that the heights were actually transferred from a certain point, okay, to where we are. Now listen to this. This is a news flash that over time, okay, we had to rely on the mean sea level to be an accepted datum based on which heights have been measured. Okay, the mean sea level. Now you think about it. So if I'm in Kumasi, there's no sea there, but I have a height that tells me how far I am from the level of the sea, the average value. Okay, so it should tell you that the sea level is being monitored, okay, over years, like over a long period of time. It's measured, and then the mean and average is worked out. Okay, then we can now start measuring from that point. So you can actually go to the harbor and have a look at it. Okay, so whole to part means that you have some points that have been accurately established in terms of height. Okay, so some of the points have been there for ages, and it's possible that there's been subsidence. What do I mean by that? If you put the vertical control on a permanent structure and the structure sunk, which is possible, all soils compact with time, the rain and everything, you may have some little bit of a sinking, so you can now, it's important, the point we made is that it's important to establish your vertical controls in such a way that their values don't change. So let's look at these things. The positions of TBMs, so these are like temporary transfer benchmarks, that's what you call it, should be fixed during the initial site reconnaissance so that their construction can be completed in good time. Okay, so you need to select where you even put it is even, let me just say, it's more important than the value you associate with it. In other words, you have to put a mark there, then you actually level to the point to give it a height value with reference to the datum, the MSL. Is that okay? All right. So you can use, typically what you see on the board is a bolt, which is actually fitted to a piece of angle iron. Okay, so angle iron is looking more like it's angled, isn't it? Okay. So where's my whiteboard? It's disappeared. Where did it go? Okay. So I just want to, show you what I mean by that. If I have something like this, so that's an angle iron. Are you getting that? And now you have the bolts going into it. I mean, going back to the diagram, I just want to bring attention to that word angle line, so that you can remember at least something. You can see that there's a bend, it's kind of bent, and then we have the bolt on top of it. Okay, So this is no joke, eh? It has a value that will control your work. All right. So that's the bevel top, that's the set bolt, then that's the angle. Are you okay? So the angle is that thing. Okay. The metal kind of bends. All right. So let's carry on from there. So in practice, 20 millimeter diameter steel bolts. If you don't know 20 millimeters, you don't think about it. You're becoming an engineer. You should go to I only see 20 millimeters. You should see that this is it. I told you the last time. Bolts 100 millimeters long, driven in. So 100 millimeters. How long is 100 millimeters? 1,000 millimeters is what? 1 meter. 1,000 millimeters is 1 meter. So 100 millimeters. What is that? Okay. What is 1 centimeter? How many millimeters make a centimeter? Okay. So, guys, as an engineer, these values should be. I'm advising you. Okay. It's driven into existing door steps, ledges, footpaths, low walls, and so on. I do. So why you usually think about it? There's a reason why you want to put them at certain places, recommended places. Any TBM constructed on the side of a wall should be such that the base of a leveling staff will always be at the same reduced level every time displayed on the mark. So it's not like you place it on a wall. One moment when you put it there, you have one value. Another time you put it there, you have another one. Okay. TBMs are constructed at ground level on the site. So you could actually put it there on the ground into some kind of concrete material. I think we talked about that earlier on. So here to 10 to 20 mil protruding, okay, out of some kind of concrete material. All right, TBM number is now scratched or etched into the green concrete. Is okay. I'm not teaching English here, but the word etch, scratched. They all meaning the same thing. That means that something hard, you cut through, bite through it. And then, so here you can see the number 12 is being written there. Okay, so it should be clearly named. It's all right. It's a very important thing. Yeah, your vertical contours are no jokes. You have to be well done. Then you have about 300 millimeters, okay, of cube concrete surround. So 300 mil. Okay, how big is 300 mil? How long is, in fact, 200 mil is about this distance. I'm trying to just show you. It's about 200 mil. Is that okay? 200, 100 millimeters, 50 mil. You should know these things so that you be a practical person. You're not going to be some kind of funny engineer walking around. We don't want you around, okay? We want serious people. All right. ETBM is referenced by, and I said that by a number or a letter. And this number should be unique. I have to say it, even though we are not, it's not on the board right on the screen right now. Okay. It should be on the side plan. Should be, you can't be calling it P2. Another place you have another P2. Is when you get into trouble now, you start realizing how childish you've been if you don't check. So you need to reference it by number or letter on the side plan. And the setting out plan. Okay, so your side plan may not be your setting out plan because you're setting out, you don't want it to be cluttered and clumsy. It should be clear. There should be clarity on it so that you can tell exactly what the design is. Okay, you're not going to put a tree on your setting out plan. Are you with me? But meanwhile, there may be a tree. So that's your side plan. Okay, your setting out plan shouldn't have certain natural stuff, existing things on it. Are you with me? All right. So we should do that, and we should also protect. Are you okay? Sure. Protect our vertical control. TBM, to the TBM is a vertical control transfer benchmark. Okay, temporary benchmark is also TBM. Basically, you need to protect it. Like I said, there needs to be some fencing around. Are you okay? So here we're making use of stakes like some kind of wooden, stake. Stake is a stake. Yeah. People like to rather stick this into some meat and then barbecue it. Anyway, so there you go. So that the size of wood that can be used, 75 mil by 50 mil. Now you can picture how big that is. Are you okay? So you don't have the wrong picture anymore. They can have a 25 mil by 100 millimeter rails painted red and white. I told you that. Yes, as if I knew it. You need a flag. Are you okay? You need to flag it. You need to do it in such a way that someone will not just drive a cherry picker or some sort of, are you okay, ramper into it and destroy it, because that's what's going to control the whole. I keep saying that if people working on your side even know the phrase control, vertical control, then all you need to do is to write control. And what does it mean? Controls the whole project. That way, so you don't joke with your surveyors. It's okay. Obviously, you can sack them if you don't. Well, what if they are the managers? That's another thing. Okay, so guys, that's basically it. Any TBM set up on the side must be leveled with reference to the agreed MBM. So the MBM, the TBM, they are referring to a certain benchmark of a certain type. Are you okay? So the T and the M are just describing it. Same way as you can see, this T is for temporary. Are you okay? All right. So the accuracy of some leveling should be within the following. Okay. The accuracy of leveling should be within the following limits. The side TBM, talking about plus or minus 0.01 of a meter. What does it mean? If I level from point A to point B, okay, and I try to check the error, are you okay? I shouldn't be getting anything below 0.01 of a meter. So let's take that 2 millimeters. 1, 2, 3. We're getting 10 millimeters. Wow, that's quite a lot. For me, I think that is a lot. It's okay. 10 millimeters, that's too much. But anyway, good for you. But as you can see, spot levels on hard surface relative to a TBM to be plus 0.05 meters. So that is 1, 2, 3. That's 5 mil. I mean, yeah, 5 mil. It's still quite a lot for me. For the project that I worked on sometime past, honestly speaking, this would be just too much of an error. Are you okay? The thing with the errors is that they compile, are you okay, to the accuracy of measurement. They do compile as you go. All right, because CBMs are vulnerable, they must be checked by releveling at regular intervals. Okay, and as soon as the project has reached a suitable stage, in other words, you just don't sit down and say, well, there's not much to do. Let me just file my nail. Are you okay? I can just play some, subway surface at this point. So from time to time, just survey again. You'll be thinking, wow, if you're a student that just graduated, you'll be thinking, wow, this project leader or engineer or whatever, my boss is so wicked. Well, he just want me to go out there. It's not your boss is doing it, it's the recommendation. Okay, from experience and from research, is that you may have to re-level again just to check. Because once it goes wrong, you end up with a certain design. And I wouldn't like to live in such a house or even drive on such a road if we talk about road construction. All right. So there should be established some permanent points on the new construction. So I don't know if the point is being made clear. You're building, right? And then you had TBMs at certain distance away from your site. But as the building gets established, for example, as you finish with the slab, you can actually permanently establish a mark on these. You get it? To establish on a permanent point on the new construction. Doesn't make sense. I'm sure it makes sense. To avoid confusion, all TBMs should be clearly marked, okay, on a copy of the site plan. So we need to, like I said, it's very important that correspondingly we should actually change any changes being made, any new establishments of control, extension of control should be indicated on the plan, together with their reduced levels. Is that okay? And this should be displayed in the site office. So there's a room called a site office where engineers you always have to work from. So just make sure you do that. Okay. All right. Site trails are interesting. Site trails, very, very interesting for vertical control. All right. And I would have loved to even look at these ones, which are, 10 like that. There's this one that this one even makes a lot of sense. So let's assume you want to establish a certain construction work. You want to do this trench. This is a simple job, isn't it? We want you to get this done. All right. Now, this trench is going to hold water. Okay, and it needs to actually flow at a certain gradient. Are you with me? 1 in K or 1 in N. All right. So you now use your survey for the information from your design, and then you establish what we call these site rails. Is that okay? All right. Now that the top of the side rails, are you okay? Should now, if you drew a line, so let me just get a line tool. If you draw a line from here to here, all right, this line should have the desired slope for the trench. Okay, so these two lines should have the same slope, 1 in K, or K percent, whatever, J percent, P percent, Q percent. Please, I hope we are doing some revision here, right? Okay, so the trick is very simple. You now need what we call a traveler. Okay, now if the top, when the top of the side rails and the traveler all lie in line, then that means the required depth has been reached. Okay, the required depth has been, it's just, I don't know, sometimes it's difficult to even explain this. It's just common sense that if you had a side rail, are you okay, which was the same, if you, that thing there, that T looking thing, which is actually called a traveler, are you okay, if you brought it right there on top, then you can actually achieve, the depth that you want if the height has been set. Are you okay for you? So for example, on the left hand side, you can see the traveler marked with its length. Are you okay? So this is a 2 meter traveler. Is that okay? And then we can just check. So here, the traveler is inside the trench. We dig in, we are checking until the traveler reaches this height, this level. We keep digging. Yeah, like my niece would say, keep digging. You digging, keep digging. Yeah. So this has to be at this level. So currently, it may be up there somewhere because we haven't dug anything. So the whole T will be, the whole traveler will be higher than this. So if you stood at one end of the side rail and you look at the other, okay, such that the tops are actually coinciding here, you will now have the T way on top. So you say, just keep digging, I'll check for you. Then don't forget, we're not only digging at this place, we're digging all along, all the way to the end. So we need to make sure that we are digging a certain slope. This is the use of a side rail. I don't think it needs to be overemphasized. Okay, don't need to overemphasize this. The same thing is happening here. So here I want to achieve a certain slope. Are you okay? For an embankment, are you okay? Or we want to just do a cut through. Are you okay? So this cutting or embankment, whichever way you want to look at it. All right. There is a side slope. I hope you remember that the side slope here, 1 in S. All right, in that calculation. Practically, this is what you do. So you may have done all your calculation, but in the end, we need people on the ground wearing boots, and you know, there's mud everywhere. Practically, you make use of these. All right. So the side rail. The side rail consists of a horizontal timber cross piece. So I've described what we want to use it for. Just look at it with our eye and make sure that the traveler is actually on the same level. Then we would have achieved the depth. Okay, but what does a side rail entail? Is simply a horizontal timber cross piece nailed to a single upright or a pair of uprights driven into the ground. Okay, so basically that is that. The traveler is similar in appearance to a side rail on a single support. Okay, so I think this is like English, yeah, English language, your ability to now describe something called a traveler, and you need a lot of imagination as well. The length from upper edge to the base should be a convenient dimension to the nearest half meter. Okay, so that's just another English language for you right there. The side rails are set some convenient value above the required plane, and the travelers are constructed. Okay, so that their length is equal to this value. Okay, all right. So as excavation proceeds, the traveler is sighted in between the side rails and used to monitor the cutting or the filling. So here you can see there's insufficient excavation here because our traveler is too high above the line defined by the side rails. Okay. All right. And here we are too low. So what does it mean? It means we need to fill to bring it up. So until we see it coming up close to the top, I think you can see my pointer. Sorry about that. So here, there's a need for a fill. Here, there's a need for a cut. Okay. Now, which one of them is a side rail? Which one of them is a traveler? How do you know in this diagram which one is a traveler, which one is a side rail? I know you will not mind me, so answer it yourself. When you watch, if you watch this video and you don't understand this question I'm asking you, you can test me, okay? Because I think the Zoom online lectures have a disadvantage. Students can't respond when you ask them questions, which is a shame. Yeah, but I think I see a clear online, but a clear, if you can hear me, you can answer the question. You are always cooperative in class. That's good. How do you know from the diagram which one is the traveler and which one is the side rail? Okay, Ekia to remind me. Ekia has been busy. All right, no problem. I never work alone, but yeah, I'm used to just being alone, you know? Okay, so the ones that gone below the ground are the side rails, and the ones that are on top of the ground are the travelers. Okay, great. Let's move on. We don't have forever. I think time is up almost. And here we have a free standing traveler. So the traveler, someone could just hold a traveler, but you could actually construct it in such a way that you can move it, okay? And with your side rails, you just move them around. So the next time we see a construction site, just look so that you can identify, okay, some of these things. All right. So that is that. Okay, for controlling the side slopes, the embankments, and cutting, sloping rails are used. So the sloping rail is what we are looking at here. So here, these are sloping rails. Another name for the sloping rails is a batterboard. Okay. Yes. Equia, is that you? Hello. Equia, your line is.
Can you please go to the slide? Yes.
Okay, Equia, say it again. I didn't hear you.
Yes, the internet is not stable here, but I'm managing. I was asking on.
Okay, I just go straight to ask a question. I can't hear you at all. Didn't hear what you said.
Said the slides you asked the question on. I'm asking about the slides you asked the question on.
Okay.
I want to see that slide again.
Okay, all right. Okay, going back to it. That's the one. Yeah.
Yes, sir. Please, what question did you ask?
The question is that which one of these rails is traveler? Which one of them is site? So the site rail is traveler rail, if you like. Which one of them is a site rail? Which one of them is traveler? How do you know? So what is what evidence do you have to show to prove that which one of them is traveler, one of them is site? So you have about 4 of them here. 1, 2, 3, 4. Right on the left hand side. Here on this side, which one of them is traveler? Which one of them is site rail? How do you know? How do you prove that? Definitely this one is a traveler. Or this one is a site rail.
I don't know.
So again. Okay.
I don't.
You don't know. Okay. If I'm here, you say you don't know. Okay. So the one that is buried, is the site rail. So you can see that. How do I know one of them? The one that is buried is the one that is going below the ground level. Yes. So you can see that this one, this is a side rail. This is a side rail. Okay. But these two are travelers. These two, this and that, they are travelers. In other words, it's only one of them you're probably using. But of course, you can build so many of them, depending on if you need them. Are you okay? If you need a lot of them, so that you can be checking, but one person can just be checking on so many people. In fact, this even looks more like the laser, the laser level, which can be set on site. So as you're working, you always know whether you are within a certain, you are at the level you're supposed to be. Okay, so these are the modern ways of doing this. Okay, but of course, if you are constructing a road, lasers may not be the ideal thing, but if it's work, you can use it. You can use laser levels, but the concept is the same. That you somehow fix a plane, a level, the line of sight, and that line of sight has a certain gradient, and then based on whether you are above it or below it, then you are too low or you are too high. Too low, you need to fill. Too high, you need to cut to achieve the desired gradient. Yes. I hope it's clear to you, Akira. It's a bit clear. So for an embankment, the slope rails usually define planes parallel to but offset. Are you okay? Some vertical distance from the proposed embankment slopes. Okay. All right. So the slope rails are usually defining planes parallel to, but do you know what that means? That means, let's go back to this diagram. So this diagram, I think it came in the wrong place, but you can see that here there is an embankment, oblique side rails, which are actually called butterboards. I'm not named for these ones are the butterboards. Okay, sloping rails or butterboards. They are offset from the actual slope. In other words, in this diagram, they seem to be flashing with the actual slope, but that's not the way they're done. They're done in such a way that they are going parallel and offset from the actual surface. Is that okay? Now, if it's a cut, you have a challenge to whether to set it directly along it or to offset it. Okay. And so you need to consider there are two options that you have. Okay, so here we have more on it. We can also horizontally offset a distance of 1 meter from the toe of the embankment to prevent them from being covered. All right, so makes sense. I don't want to even think about it. Travelers always use income. When we, the idea is that when we actually, we have one more discussion. What time is it? Actually, you can always make a suggestion. I think we started at 10:30. So 10:30, 11:30, 12:30, 12:30. So when are we supposed to 1:30, isn't it? So we still have like a little less than an hour to finish. Okay, so I'll talk about one more topic after this one. Then we can say goodbye. All right. So basically that's I don't know what happened to my previous one. I don't know whether the recording is continuous. I don't know, but let's carry on. If I'm not able to share the video on the previous discussion we just had, then that would be a shame though. But yeah, the disconnection didn't help. Yeah. Okay, so we talked about slope rails or butterboards. Is that okay? All right. And they have boning rods. So you can imagine that all these are supposed to help you. Please go and read about boning rods. Let me write it down. Please, it's an assignment. Go and read about boning rods. Boning. Read about it. Okay. Read about boning rods. Read about it. So it's becoming apparent in the diagram that we see on the board exactly how the cuts and then the fill, are you okay, are done. Okay. All right. So remember we did some calculations on this one, a W/2 and all that. That was like a lot of theory, but in practice, someone can just go and start constructing this without even doing any calculation at all. That's sometimes the wisdom behind some of the things we are teaching, that in the end, you need to get it done. Okay, on the ground, you need to get it done. So slope rails are the main thing. They use in conjunction with the traveler. Slope rails. Okay. So this diagram, so we can have additional slope rails. Like I said, you can have a lot of them. It depends on you. And of course, the economics of whatever you are doing. Money is everything. Yeah. Chances all things. That's what the Bible says. So formation level, till we get to the formation level, how do we know we're there? Are you okay? All right. So we just keep going. So is this hanging in the sky? Okay. Anyway, okay, our line is bad, so don't answer.
Yeah.
Oh, go ahead. Is this slope rail hanging in the sky?
No, sir.
Okay. So please, guys, sit down, read. There's a lot to read. Okay, on these things. I think. Yeah. For cutting the slope rails, I've said this already. Let me repeat it again. For cutting, the slope rails can be set in two ways. You define out the actual slope of the cutting. So remember that the cutting. Let me just try and do an example. Then have the ground looks funny like that, and we need to cut through. So the design goes like that. We need to cut. Are you okay? So here there's a need to cut, right? Clearly, we need to cut this portion, cut it off. Yeah, it reminds me of a certain kid.